All right, so if you take a look, like I said, the plan for today, we spent a day last Friday on exponential functions, looking at growth, decay, all the different options. Then yesterday we did applications of those exponential functions. Now we're going to get into logarithms, because simplest way to describe a logarithm is it's the opposite of an exponential function. It's the inverse. Okay, and so we'll get into that. We're going to use logarithms to solve exponential problems. Okay, later on. So today is kind of looking at the definition of a logarithm and then just evaluating log functions. Okay, so we'll talk about that. All right, so a little bit of a kind of lead-in examples here. 2 to the x equals 8. What's x? 3. 2 to the third power equals 8. Okay, let's do a couple of these. 4 to the x equals 16. What's x? 2. X squared, okay, or 4 squared gives you 16. How about 3 to the x equals 81? 4, it turns out to be 3 to the fourth power. Okay. Now here's the relationship. So those are all exponential equations. And eventually where we are headed is, well, what if it's not 2 to the x equals 8? What if it's 2 to the x equals 10? It's not a nice number. How do we then get an answer? That's where logarithms are going to come into play. We're not going to worry about that today, but that's where logarithms will come into play eventually. Okay. So here's what I want you to take a look at. We said we were trying to find the exponent. We're going to go to I told you to take the calculator out. We're going to go to that here in just a second. I'm going to rewrite this as the log base 2 of 8. And we're going to type that into the calculator. Log base 2 of 8. And take a look and see what we get. So if you go to your calculator, let me switch the input here so you can see. And when you notice there is a log button right next to the 7, that log button, though, however, when you push that, if you notice, it does not have a base written here. Okay, we'll talk about it later in the lesson, but logs are normally base 10. Okay, we have a number system that's base 10, therefore logs are base 10. Okay, so that's why if there's never a base written, it's assumed that it's a base 10. Well, that's not what we were just working on. We were working on base 2, so we got to figure out how can I redo that. So here's how you can do it on the graphing calculator. If you hit the math button, it's right below the green alpha button. And what I found in the other class the other day, earlier today, most people had this. There were some people who did not, and I was able to at least figure out a fix, and then we'll go from there. So if you're in the math category here, and let's say you arrow up, what you should be looking for is right here where it says log base. Okay, I've got it listed as the letter A. You should have the log base is what you're trying to do. Anybody not have it when you go into the math button and arrow up? Anybody not have that? Okay. You may not. Like I said, there were 2 or 3 people in my other class that didn't have it, and I'll fix it when we get to work time. But for now, if you don't have the log base, right now all you have on your calculator then is base 10. There's still a workaround, but we're not going to use it. We're going to just fix the calculator. Okay? So if you go to log base, here's the nice part about that one. You hit enter. Now it gives you a spot to type in the base and a spot to type in the argument, whatever you're taking the log of. So that one we were doing before, I said log base 2 of 8. You can now type that in directly. You hit enter, and we get an answer of 3. Which, isn't that what we said? 2 to the x equals 3. Okay, or 2 to the x equals 8. We said x was 3. The point I'm trying to make on this one is this. The log is doing the same thing as what we were doing in our head before. All this is saying is 2 raised to what power gives you 8? That's why it's 3. If we do the next one, or the log base 3, the 81. Let's say we go to the log base. And we type in log base 3 of 81. And we hit enter. There's the 4. 3 to what power gives you 81? That's what the log is doing. It's telling you what the exponent is. 3 to the fourth power will give you 81. 2 to the third power gives you the 8. Okay, so it's giving you the exponent as you work your way through that. All right. So let me go back to the actual lesson. That's where the log base is on the calculator. We're going to keep going with the lesson here. So that's what's happening here when I said log base 2 of 8 is 3. When you take the log base 2 of 8, it actually tells you the exponent in this problem. In this one that we just did, we did the log base 3 of 81. We just typed it in. It told me the exponent on this problem. 3 to the x equals 81. It was 4. Okay? Let's do one more just in our head. 10 to the x equals 1,000. What's x? Okay, yeah, turns out that it's 3. This one, people that don't have the log base on your calculator, this one you can actually do, because it's base 10. You could actually type in the log of 1,000, and you should get, you should get 3, okay? Again, if there's no base written, it's always assumed that it's base 10. That's what logs are in general, okay? So general thing that I want you to understand is that logarithms help you find the exponent. That's what you're finding as you work your way through it. Okay? All right, here's your definition, probably the most important part. Being able to work back and forth between exponential and logarithmic form. We're going to come back to this definition multiple times throughout the chapter and use it. And that's why I say it's probably the most important part. And here's the definition right here. So here's your y equals b to the x. There's your exponential equation. And then by definition, like I said, you could rewrite that in logarithmic form. First thing I want you to notice, because this is where we're going to start every time, the base in exponential form, base b, is the same as the base in logarithmic form. Bases stay the same no matter what form you're in. Okay? We said that when you take a logarithm, it gives you the exponent. Well, notice the exponent is x. Therefore, that's what equals the logarithm. Okay? And again, you're going to hear me say a term. You're going to hear me say the argument. The argument of a log is whatever number you're taking the log of. So if I asked you for log base 3 of 81, 81 is the argument. Okay? It's what you're taking the log of. So in this case, the y is what's called the argument. It's just when you hear me say that, that's what I'm getting at. Okay? Notice there is a couple of things that go along with this. Both b and y are positive numbers, and b cannot equal 1. That's basically coming from the exponential side of things. You have to start with a positive base, okay? And part of the reason why y ends up being positive is if you've got a base that's starting off positive and then it's growing exponentially or even decaying, you're going to end up with a positive answer regardless. If you start with something positive, you end with something positive. Which leads over here. In this case, that means you cannot take the log of a negative number. Okay? When you're in logarithmic form, we said y has to be positive. I can't take the log of negative 5. And we'll talk about why as we go through it in a little bit. Okay? But there's your definition that we're going to go through. And like I said, this allows us to solve for x if it's in the exponent. That's what a logarithm does. All right. So here's your first example. You're given something in logarithmic form. I want to rewrite this in exponential form, just so you can kind of see it from both perspectives. So like I just said, I'm going to keep coming back to this one. We start with the base, always. Log base 3 means we're going to have 3 raised to some power. What's the power going to be out of this? Is it the 81 or the 4? Yeah, remember the log always equals the exponent. That's what a logarithm does. It gives you the exponent. So this is 3 to the 4th equals the 81. It's the exact same thing written in logarithmic form versus exponential form. Okay? Log base 3 of 81 equaling 4 is because 3 to the 4th power equals 81. I'll give you another one. And one of the things you're going to find today we're going to start revisiting some of those exponent properties. Like in this case, we've got a fraction. Okay, we're going to talk about fractional exponents a little bit. We'll talk about negative exponents, things like that. Log base 9, therefore I start with the 9. 9 raised to what power? The 1/2, yep, whatever it's equal to. 9 to the 1/2 power equals 3. There's the exponential version. Now, let's revisit real quickly the fractional to make sure that that's making sense. Remember back to last year, that 1/2 power is really the same thing as what? It's the square root. 1/3 power, remember, was the cubed root. 1/4 power is the fourth root. So this really says the square root of 9 equals 3. Okay, that 9 to the 1/2 power is the square root of 9. So, quick refresher on that. Let me give you another one. Log base 2 of 1/8 equals -3. Again, we start with the base. Base 2. What power am I going to raise the 2? 2 to the -3rd. Okay. Again, whatever the log equals is always the exponent. That's what a log does. 2 to the -3rd equal to the 1/8. Anybody explain why 2 to the -1/3 is 1/8? Now we got to go back to negative exponents again. That's exactly what it does. A negative exponent, remember, drops it to the denominator. So 2 cubed is 8. 2 to the -3rd is 1/8. Okay? So it always takes whatever you normally would have and drops it into the denominator, creates a fraction when you're dealing with negative exponents. So therefore, these two are the same thing. Okay? Part of your assignment today is going to be working back and forth between logarithmic and exponential form. Part of it will be evaluating some stuff on a calculator. Some of it will be evaluating stuff without a calculator, okay? Which we'll get into. We'll talk about that when we get there. Let's try working the other way. Here's exponential form. Let's rewrite it in logarithmic, just so that you're comfortable working back and forth between both forms. So now, same thing. I'm still going to start in the same spot. Base in exponential form is the base of the logarithm. So I know this is log base 3. Where's the 2 go? Where's the 9 go? If I'm working the other way. And here's what I would tell you. In my opinion, this is the easiest way I would think of it. Okay? Remember, the log always equals the exponent. So it's got to be equal to 2. Which means the 9 is that term I was talking about before. That's the argument. Okay. If you then look, just to double check to make sure it makes some sense, look at what you have. If you ignore the equals 2 for a second, 3 to what power gives you 9? 2. That's what this is saying when you're looking at a log. 3 to what power equals 9? Let's do another one. Log, what's my base? Log base 3, yep. So we start there. And once again, we figure out which one's the argument, which one's it equal to. What is this equal to? Let's start there. The -2. Log always equals the exponent. Equal to -2, which means 1/9 is the argument. Log base 3 of 1/9 equals -2. And again, if you think about it for a second, 3 to what power gives you 1/9? Well, we said 3 squared gives you 9, so 3 to the -2 drops it into the denominator. That's where it becomes 1/9. Okay. Questions on that at all? Okay, it'll give you some practice. Like I said, part of your assignment today is working back and forth between the two. Okay, let's keep going. Let's evaluate without a calculator now, at least a few of these, and that'll lead to a few properties that we'll then talk about. Log base 3 of 27. Let's do it in your head. What do you get? What is it? 3. Why 3? Yeah. What this actually says, the way you need to think about this is 3 to what power gives you 27? answer is 3. Okay? If you wanted to think about it in the other class, somebody kept coming back and looking at this and saying, well, what that really is 3 to what power equals 27? That's really what this is asking you. Okay? And it is. That's just the exponential version of this. How about the next one? Why 0? 4 to what power gives you 1? Remember, again, it goes back to some properties of exponents. Remember, anything to the 0 power always gives you 1. This will lead us to a property in general, by the way. What if I change that to log base 5 of 1? What's the answer? What if I change that to log base 10 of 1? Therefore, what's the log of 1? 0. Doesn't matter what the base is. The log of 1, regardless of the base, is 0. Okay, that's just a general rule that eventually, the more we work with this, you should just know off the top of your head eventually. Okay, how about log base 5 of 5? 1. 5 to the first power gives you 5. Okay. What if I had log base 7 of 7? 1. What if I had log base 2 of 2? 1. Which means anytime the base and the argument are the same, the answer is 1. Okay, which again, we'll talk about that more formally in just a second. But that's the idea. 1. Actually, I've got 2 left. How about this one? Log base 6 of negative 1. This one's a tricky one. What do we think? 6 to what power gives you negative 1? It's not 0. It's not 1. But I know just based on those answers, you're in the right you're in the ballpark. It's not negative 1/6. That's also a good guess, though. This goes back to our definition. You can't take the log of a negative number. There is no power that you can take 6, raise it to, and get a negative answer, which means this one is no solution. Not possible. Okay? And that's why I put that one in there, because I wanted to go back to that definition of a log again and remind you, you can't take the log of a negative. If you start with a positive base, which you have to, that's part of the definition, that means if you start with a positive number, you're going to end with a positive number. There is no power that you can raise and get a negative answer. Okay? 6 to some power does not equal negative 1. Last one. Let's see if you can get this one. And I don't know why I went back to 3, but it did. Log base 5 of 5 raised to the 2/3 power. Any ideas? This one's also a little bit tricky in terms of messy. If you can't think of it in your head, here's what I want you to think of. Think of it in like exponential form. 5 to some power, I don't know what power, that's what we're trying to figure out, is going to equal 5 to the 2/3. And therefore the answer is 2/3. Okay? 5 to what power equals 5 to the 2/3? Okay? Just like here, we said 3 to what power equals 27. Here we said 4 to what power equals 1. Here we said 5 to what power equals 5. It's still the same thing. You can think of it in terms of like your exponential form. 5 to what power equals 5 to the 2/3? 2/3. Okay? And again, the reason why I bring this part up is up here we said anytime your argument and your base are the same, we have an answer of 1. Here, if we add an exponent to that, your answer is the exponent then at that point. Because remember, that's what we're finding. Okay? And like I said, we'll add some properties. This will make some more sense as we move forward. All right, which leads us, and we kind of talked about it, but here's the formal slide of being able to do this. So 4 special properties. Number 1, the log of 1 is 0, regardless of the base. Like I said, we already talked about that. Doesn't matter what your base is, because anything raised to the 0 power gives you 1. We already talked about this one. Whenever the argument, this is what we were just talking about, whenever the argument and the base are the same, we know the answer is 1. Because the base raised to the first power gives you the argument. Okay? Gives you the same thing. So log base 5 of 5 is 1. Log base 7 of 7 is 1. Log base 10 of 10. We just talked about this one. This was that 2/3 problem. Anytime the base and the argument are the same and there's an exponent involved, the answer is the exponent. Okay? And again, which kind of hopefully makes some sense because that's what a log is finding. It's finding the exponent. Well, the exponent in this case is x. The exponent on that last one was 2/3. And the last one, which we haven't dealt with yet, but it's going to come into play, especially as we move forward, is if two logs are equal to each other and they have the same base, that means their arguments then will be equal to each other. Okay? If log base v of x equals log base v of y, that means x must equal y. That's going to more come into when we're starting to solve equations. All right, last thing that I have for you, and then I'm going to go back to the calculator again real quickly. And we already talked about it a little bit when we were talking about the calculator, but you have basically two types of logs. You have a log base, whatever, 2, 3, 5, 10, whatever it is. And then you have a special one, which we talked about earlier, when it's base. There's base 10, which is, like I told you, that's the log button on the calculator. Okay? So that's just the log of x. If it is base e, that's a special type of log, which we've talked before. Last week we were talking about the e to the x and how to type it into the calculator. I told you to hit second and then the ln button. That's what the ln button is. It's the natural log. And all it means is it's log base e. Rather than base 10, rather than base 2, rather than base 5. It's a special base, therefore there's a special name for the logarithm. So if you hit the ln button on your calculator, what you're actually doing is this, log base e. Okay, that's what the ln button does on the calculator. Okay, so for example, let's go back to the calculator then. I told you before, here's kind of the three options. Okay, if you hit just the log button on the calculator, oops, hit two buttons. If you hit just the log button, what base am I dealing with? This is base 10. Okay, if there's no base written, you're in base 10. If instead you go into the math button and you go to the log base, where then you can type in whatever base you want, whether it's 2, 3, 5, whatever. Okay, that allows you to do that. If I was trying to do a base e, that's where the natural log button is going to come in. I don't have to type in log and then put the e in there. You just hit the natural log button instead. And let's say I wanted to know e to the x equals whatever, 5. I would take the natural log of 5. All this is saying is e to what power gives you 5? And the answer is not so nice. Okay? You're not going to get very nice answers when you're dealing with e because e is not a nice number. Okay? But that's the only difference between natural logs and regular logs, base e. Okay? One last thing as I mention this, then I'm going to give you the assignment. I told the other class, so this is going to take us to after Thanksgiving. We've got a couple of weeks of logs and exponents and all the stuff in this chapter. However, the test on this one is going to be a two-part test, 2-day test. Okay? Part number 1 will be a no calculator part. Okay, and the reason I'm telling you that now is because of these types of problems. When you get to problems that say evaluate these without a calculator, don't go typing them into the calculator and just write the answer down. Because on day 1 of the test, you won't have a calculator to just write the answer down. Okay? So try to think about, all right, log base 3 of 27, log base 401, what do I actually get? So you're understanding a logarithm, okay? On day 2 then, once we actually go through and start solving, then you need a calculator. You're going to have to use a calculator to do some of the solving. And so just a heads up in advance, the difference between the 2 days, okay? So when you see that, don't ignore the no calculator. Try to make sure you're understanding it and evaluating it, okay? Otherwise, what I have for you, there's the assignment. Page 203, numbers 1 to 41 odd. It looks like there's a lot of problems. The other class had about the same amount of time, and most people finished before they left. Okay? Because there's not a lot to it. It's pretty much just rewriting it or a quick evaluation. There's not a lot going on here. So 1 to 41 odd, and go from there. Okay? I will come around, by the way, and check and see if on your calculator you don't have the log base. I will come around and try to fix that for you. Okay? Let's go to work.